Hi, in this week's lab, we are going to explore limiting reagents and stoichiometry of limiting reagents using the Chem Collective simulation. So in the stock room of this simulation that's in your lab manual, there are two solutions, solution 1 and solution 2. Solution 1 is silver nitrate solution and solution 2 is sodium chloride solution. Your goal is to determine the concentrations or molarity of each of these solutions. So let's look at the concept. So molarity refers to moles of dissolved substance that's there per liter of solution. So for silver nitrate solution, if you want to determine the molarity of it, you need to know how many moles of the dissolved silver nitrate is there in any given volume. So you can easily select a certain volume so you know the denominator. So now the only question remains how many moles of silver nitrate is there in that volume. So to determine that, you will use a reaction stoichiometry. And the reaction is basically the reaction between the two solutions. When silver nitrate solution reacts with sodium chloride solution, it produces an insoluble solid, which is called the precipitate. It's going to be a precipitate of silver chloride. So here's a visual. When the two aqueous solutions react, you're going to generate the silver chloride precipitate. Now notice that the molar ratio is 1:1. Silver nitrate and sodium chloride react in 1:1 ratio, and they also produce silver chloride in the 1:1 ratio. So in the first part of the lab, you're going to react equal volumes of each of these solutions. Now, equal volumes doesn't mean equal moles because one solution can be more concentrated and it can carry more moles than the other. So when you react them together, one of them is going to react completely and the other is going to be left over. As you can see from this visual, the silver nitrate is in limited quantity. So silver nitrate is going to react completely. So 4 moles, so each dot here represents a mole. So if the solution had 4 moles of silver nitrate, it's going to react with 4 moles of sodium chloride to create 4 moles of the precipitate. Now, from the information about how much precipitate was generated, you can backtrack how many moles of silver nitrate came from the solution you reacted and how many moles of sodium chloride reacted. So the idea is, since the silver chloride is a precipitate, it can be separated out. So if you were doing this in a real lab, you can isolate the precipitate by filtering it out using a filter paper. You can dry it out and weigh it and find the mass of it. So from the mass of the silver chloride formed, you should be able to backtrack how much silver nitrate was there in the solution you reacted and how much sodium chloride reacted in that solution. Now, one important thing to note is since you don't know how much you're reacting, in other words, the concentrations of the solutions you reacted, you will not know upfront which one is still left over in the solution and which one is the limiting reagent in the solution. So in the second part of so in the part B of the lab, that's your goal. You want to test this filtrate, and by the way, the solution that is left over after you separated out the precipitate is called filtrate. So you're going to test the filtrate to figure out what is still left over in it. And if you know what is left over, you know what reacted completely. So this is an exploratory type of lab. So come prepared thinking about this question. How will you test the filtrate to determine what the excess reagent is and what the limiting reagent is? Also think about suggest a procedure to determine the molarity of the limiting reagent, starting from the mass of the precipitate that you generated. Another important thing you want to think about is, can you determine the concentration of the excess reagent? Remember the backtracking moles of silver chloride to moles of each. It will only tell you how much reacted. Will it tell you how much is originally there? If so, for who? Can you determine the concentration of the limiting reagent? Can you determine the concentration of the excess reagent? So think about these questions before you come to the lab, and in the lab you will actually perform the virtual experiment to answer these questions. Your final goal is to conduct experiments to determine the concentration of each one of them.